Hello. So in this video, we'll be simplifying a four-variable Boolean expression using Karnaugh maps with don't care conditions. We want to find the prime implicants and essential prime implicants to derive our minimal SOP form. First, let's go over some definitions. An implicant is any product term that results in the function 1 for any input combination. A prime implicant is an implicant that cannot be combined with another implicant to make a larger group. So, for example, with the combination of literals W and X, which is this row, if we remove the literal X, then we result in these two bottom rows, which is the literal W, which includes a zero, which cannot be an implicant. If we go the other way, remove the literal term W, then we result in the literal X, which is these two middle rows, which also include a zero, which therefore is not an implicant, meaning that the combination of literals W and X is in fact the largest group, meaning that WX is in fact a prime implicant. Finally, an essential prime implicant is basically a prime implicant that covers at least one cell that no other prime implicant covers. And we'll be going over this in this example in a little bit. So one thing to keep in mind and a general rule of thumb with K-maps is we see the transition from 0 to 1 to 3 to 2. We only want adjacent cells to differ by only one bit to ensure proper function, which is why we use the grayscale, in which this first bit 0 flips to a 1 while the second bit stays the same. And then the second bit flips from a 1 to a 0 while the first bit stays the same. Some general K-map rules to cover. We only cover cells that have a 1 and only include don't cares if it helps you create a larger group. So for example, if we look at this middle group right here, we see that the D's in fact help us make a larger group, which then minimize the number of literals we need for that expression. So we would include the D's in this case. Number two, we can only circle groups in powers of two. So we can circle a single minterm. We can circle a group of two like this. We can also circle groups of four, which can be either a box or it can be a whole row. And finally, we can circle a group of eight in this way. Number three, we can only circle adjacent cells. So we can't circle cells in like an L shape or any other shape that's not adjacent. And we also have the rule of fluid boundaries. So basically the top and bottom rows are adjacent, the left and right columns are adjacent, and the four corners are also adjacent. So another valid group on this K-map would be the four corners because they only include ones and a don't care, which makes this group valid. So aside from this problem, the K-map minimization procedure is as follows. So first we want to find all of the prime implicants within the K-map. And then from that, we want to determine all of the essential prime implicants and include those in our minimal SOP form. And after that, we want to remove all of the dominated prime implicants, which are the prime implicants that the essential prime implicants cover. Following that, we want to then find secondary essential prime implicants and tertiary essential prime implicants and keep repeating this process until the K-map has no more ones left, which would then make our minimal sum of products form.